Fine. First topic, we'll start with the complex numbers. Now, say, let us consider one equation. The equation is x squared plus 1 equal to 0, right? This looks like a normal quadratic equation, and we try to solve this equation means we have to put different values of x to this to satisfy this equation, right? Different values of x we can put, and we have to find an x such a way that x uh, plus x square plus 1 should be equal to 0. Otherwise this implies we have x is equal to, right, square root of minus 1. 1 goes to the other side, x square equal to minus 1, and that implies x equal to square root of minus 1. Right. Now this actually has no real roots, right? This equation has no real roots. Okay, so this concept was studied by Euler, and he suggested that since there is no real root, let us assign the imaginary, the root is imaginary. There is no number which has, right, a power as negative number. Right, whenever you square any real number, positive, negative, or even 0, right, we are expecting a positive answer, non-negative answer, right? So since the square of positive or negative or 0 is always positive, right? Minus 2 square is plus 4, okay, and plus 8 square is 64. See, irrespective of whether the sign is positive or negative, when you square a number you always get a positive number, right? Since square of positive number, negative number, or 0 is always positive, right, the this implies root of minus 1 is not a real quantity, right? This means we call it as it's a imaginary quantity. Imaginary. So the imaginary quantity is denoted by, right, we try to denote this imaginary quantity by denote root of minus 1 as, so we can write, we have two options, either to use I or j, okay, I or j, in the sense root of minus 1 is actually, you can use I, right, anyone. So root of minus 1 is I, in the sense, let's try to find out what are the other possible power. Can we raise it by different powers? Yes, we can raise, right? If this is the case, we can try to write the following notation. So this means, let us square both sides. I square is equal to root of minus 1 square. So square and square root will get cancelled. You have answered I square is equal to minus 1. Alright, then let's try to do the cube. This implies, let's try to write a I cube now. So I cube is equal to, this is I square into I. Correct. So what is I square? I square in the previous step we have minus 1 I square into I. So that is I cube is equal to minus I. Right. Let's calculate I to the power 4, which is I square into I square. I square is minus 1. Another I square is also minus 1. Minus 1 into minus 1 is plus 1. So we have four quantities. Now you can see that these values are repeating. I to the 4, next I to the 5 is I to the 4 into I to the 4 is 1 into I is simply I. So I to the power 5 is I to the 6. We can calculate in the same fashion. Okay, now let's come back to the original equation which we considered. Therefore, x square plus 1 equal to 0 implies, right, x square is equal to minus 1. This implies x is equal to root of minus 1, right? So you see that whenever there is a square, there are two possibilities, right? You have two values that can be substituted to get this. That means we can write x equals to plus or minus root of minus 1. But this root of minus 1 is I, so you have plus or minus I. So the answer is as x is equal to either plus I or minus I. Let's check this whether it is true or not. Put x square plus 1. This is equal to, first let's put minus I. X is minus I square plus 1. So what is minus I square? Right? So just check I square. I square is equal to minus 1. Right? So minus of minus is plus. Anyway, that's gone. Minus 1 into minus 1. I square is minus 1 plus 1 equals to 0. Put, this implies x square plus 1. X is equal to simply I square plus 1. So I square is also minus 1 plus the next one is 0. So you can see that this equation is being satisfied by both the conditions. So what are the roots of x square plus 1 equal to 0? Plus or minus I indicating answer is imaginary. That is not a real number. Okay. Now let us try to calculate some of the simple mathematics with the I. So we know that the different values of I, let's write once again. We know that I is equal to root of minus 1. Then we also know that I square is equal to square of the above term, which is minus 1. Then I can write I cube, that is equal to minus I, right? And I to the 4 is equal to plus 1. Okay, we will use these four as our standard properties of I. Now, using this we can derive, let's say, what is 1 by I. Okay, so or this can be I inverse. I inverse in the sense it's 1 by I. So just to simplify this, 1 by I, I'll multiply and divide it by I to this. 1 by I into I divided by I. So numerator is I, denominator is I square. What is I square? I square is minus 1. So denominator changes to minus 1. So this is I inverse is equal to I divided by minus 1. So that is equal to minus I. Right? I inverse can be found like this. Now similarly, we can extend this concept to find any powers of I, even negative. I to the power minus 3 we can find. Right? So for example, if I to the minus 3 is required, this is 1 divided by I to the 3. 1 divided by I to the 3 is, I to the 3 is minus I, so I can write this as 1 divided by I to the 3 is minus I, out of which the minus is taken out, into 1 by I is what? Minus I. So the answer, I to the minus 3 is equal to minus of minus plus I, and so on. Right? We can try to find out any given powers of I using this. Okay, let's go further. The next question is, okay, if at all we want to write this is root of minus a into root of minus b. Okay, so this is, we can write this as, okay, root of minus a can be written as root of minus 1 into root a into root of minus 1 into root b. But root of minus 1 can be separately written as, this is I into root a into, there is another I here, so this is I into root b. So you can see I into I is I square, root of a into b is ab, root ab. So I square is minus 1 minus of root ab. Right? This is the possible answer, right? Whenever we try to write root of minus a into root of minus b. Right? Okay, so for example, if we ask a question, root of minus 2 into root of minus 3. Okay, so root, this has to be according to the above rule, this has to be minus of root of 2 into 3, 6. Okay, now we need to be careful here because there is a chance of making a mistake, right? So we'll give a note here. So the root of minus 2 into root of minus 3 is not equal to root of, see, I can write minus 2 into minus 3 in the same, under the same square root. So you can see that this says that this is minus 2 into minus 3, which is equal to 6, right? This is not true. Root is valid only when, right, the term under the square root being positive. As soon as one of the term becomes negative, right, we cannot apply this property, we cannot club them this way. So right, this is not valid, right? This implies root of minus a into root of minus b is not equal to root of minus a into minus b, because it's valid only if both a and b, only when both a and b are positive. So you can see in the previous step, see, I clubbed root a and root b only after converting them into positive, right? Only after that, root a into root b I clubbed because both are positive now. But here you can see both are negative, I cannot club in this step. So clubbing them to the single term under root is not valid. Okay, that's a property in mathematics. All right. Right, let's go for some basic problems and basic concepts here. Right. The next concept we want to solve now is to find the I to the power n, right? Where n is greater than 4. So until 4 we know the values, right? I to the power 0 is 1. I to the power 1 is I. Let's recall. So any I to the power 0 is 1. Okay, I to the power 1 is simply I. Then I square is minus 1. And I to the power, I cube is equal to minus I. So now if you repeat, I to the 4 is 1. I to the 5 is I to the 6 is minus 1. I to the 7 is minus I, and this will repeat. But in order to find a number which is very large, like say 100, I to the power 100 is what? If we want to find, right, we have to apply, right, a simple technique, right? So our first step is, right, to find I to the n with n greater than 4, right? Our first step is divide n, whatever is the n value, divide n by 4 to get, let us say there is a q for quotient. Q is the quotient, and let us say r is the remainder. All right. This means I can write the n is equal to 4 times the, because you are dividing by 4, so 4 times the quotient plus r, right? So this r will be always 0 to 3, correct? So since 0 less than or equal to r less than or equal to 3, right, we can always calculate in this fashion. I to the power n can be represented as I to the power, right, n is equal to, this is 4q plus r, because n value we just found that n is equal to 4q plus r. So instead of n I can write 4q plus r. Okay, so this is equal to, now we'll split the terms. If you have I to the power, or any number, it's not required I only. Say if you have x to the power a plus b, I can write it as x to the a into x to the power b, right? This is the basic rule in algebra. So we are going to apply the same here, right? I can write this as, see, I to the power 4q plus I to the power r. I to the power 4q into I to the power r. So this is I to the power 4q into I to the power r. This is equal to, I to the 4q can be written as I to the 4 to the power q into I to the power r. Okay, but what is I to the 4? From the equations we have written just now, you can see that I to the power 4 is 1. All right, so this is 1 to the power q into I to the power r. So this is simply I to the power r. This is what I need to find. I am very sure that r will be, right, always between 0 and 3, right? Because whenever you divide a number by 4, right, the possible reminders will be either 0 or 1 or 2 or 3, right? So I just have to remember these 4. I don't have to remember I to the 4, 5, 6, 7. I just need these values. Okay, so since you need only these values to be remembered, right? It becomes easy for us to solve, right? For example, if I to the power 21 is asked, right? When you divide 21 by 4, 1 is a remainder. So I to the 21 is I, because I to the 20 is gone. I to the 20 plus 1, right? I to the 20 is, it's a 4 into 5 is 20. I to the 20 is 1 into I to the 1 is I. Okay, we'll solve problems based on this. First question. So say let's try to find the value of I to the power 1998, right? So let's simply divide the 4. We are trying to divide 1998. So this is 4 9 9. Yeah, sorry. 1996. So see, 2 is a remainder. So I to the power, this is nothing but I to the power, this is 4 into 499 to the power 499 into I to the power 2. So this is 1 into I square, I square. So what is I square? I square is minus 1. Okay, straightforward. Next question. Want to write, say, I to the power minus 9999. Okay, so let's divide 9999 by 4. This goes 2499 to get 9996. So this is, the remainder is 3. So this can be written now as, anyway, let's write this is, first we convert this into, we take it to the denominator, e to the power 9999. So this is equal to 9999, in the sense this is 1 divided by, anyway, 999, instead of writing 9999 I can simply write 3 now. This is I to the power 3. Anyway, previous step we understood the technique, so we'll simply write I to the 3. 1 by I to the 3, right, can be written as, what is I cube? I cube is minus I from the standard list. See, I cube is minus I. So this is minus I, right? 1 by minus I. So out of which I'll take the minus outside into. I'll check what is 1 by I. That is also there in our list, standard list. 1 by I is equal to minus I. This value. 1 by I equals to minus I. This is minus I. Minus of minus is plus I is the answer for I to the power minus 9999. Okay, let's go to the next question. Let's try to solve this. If, say, alpha is equal to 1 plus I divided by root 2. find alpha to the power 1929. Okay, now we apply the same logic, right, as we did earlier, but not for I, but for alpha. What we do, we'll calculate the powers of alpha. So let's calculate alpha square, right? Alpha square is equal to, this is 1 plus I divided by root 2, its square. Okay, this is not I, this is 1. 1 plus I, the whole square. So it's like numerator square by denominator square. This is 1 plus I square divided by root of 2 square. So numerator a plus b whole square formula. This is a square plus b square, that is I square. I square is minus 1 to ab. A square plus b square plus 2ab. 2 into 1 into I is 2I. Whole divided by root 2 square is 2. So we can see this getting cancelled. Plus 1 minus 1 cancels. 2 divided by 2I. This is 2I by 2, in which we can see that 2 getting cancelled. So alpha square is simply I. Why we calculated alpha square? Because this alpha to the power 1929 I divide by 2, right? 1929 divide this by 2. So this is simply 964 times. So I get 1928 and 1 is the remainder, right? This implies now alpha to the power 1929 is equal to alpha to the power 2 into 964 into alpha to the power 1, right? Alpha to the power 2 into 964 can be written as, so the same number will be squared once again. You see, alpha square whole square. Right. So this means I can write this is alpha square to the power 964. Correct. So alpha to square to the power 964 into alpha. Okay. But what we do here, this now becomes equal to alpha square is just now calculated as I. So this is simply I to the power 964. I know how to calculate I to the power any number. Divide that number 964 by 4. Okay. This is this is 241, right? And this is 964, which is 0. So 0 is a remainder. So I can write this as I to the power 4 into 241 into alpha. So I to the 4 is 1. So 1 to the power n number is 1 only. So this is 1 into alpha equals to alpha. Alpha's value is already given. That is 1 plus I by root 2 is the required answer. So that is nothing but alpha to the power 1929 is alpha itself. So we can try to find the answer in this way. Okay. Let's go to the next concept. Here we try to find out a concept that sum of 4 consecutive powers of I. So for example, we are supposed to calculate, let's say I is equal to root of minus 1. This implies you take I to the power n plus I to the power n plus 1. Maybe n is equal to 4, then I to the 4 plus I to the 5 plus I to the 6, that is n plus 2 plus I to the power n plus 3. Right? So this means we want to calculate this. That's what is the term sum of 4 consecutive powers of I. So this can be written now equal to, let's say, I to the n into, right, you have the terms coming up. When I to the n goes out, there is 1, right? This is 1. Then I have I to the power n has gone out. I am left with I here, plus I to the power 2 left inside this, so I square is minus 1, then I cube is minus I. So you see that this term is a 0, so this is I to the n into 0 is 0, right? Now ultimately we can try to write this summation, sum of any 4 consecutive powers of I equals to is a 0. That's the point which we are going to learn. Okay, now let us try to evaluate the following terms. Okay, there is a note to remember. This is in general, right? If you have a summation, sum of r starting from a number till another number, r is equal to 5 to 100. Okay, so that's what is the meaning. Any function f of r can also be written as the same summation starting from 1. Now I should reduce p terms from my above term, correct? It was starting from p and going till m. Now I want to start the same function from 1, means I should actually subtract 1 lesser than n plus p. So this is m minus p plus 1. So see the change in the term. This is f of, so every r becomes r plus p minus 1. Same thing, if you have summation r being negative minus p to m f of r, this is equal to, these are the two formulae which we need to remember. Okay, this is r starting from 1 and going till m plus p plus 1. Okay, so f of r minus p minus 1. So two important formulae to be used. So how to apply this in a problem we will discuss later. So these are the two formulae needs to be remembered in order to solve the problems. Okay, going ahead. So question is to find the value of sum of n starting from 1 till 13 I to the n plus I to the power n plus 1. Right? We know that this I is equal to root of minus 1. So whatever is asked, we can split this as n is equal to 1 to 13. First term is I to the n plus one more term. N is equal to 1 to 13 I to the power n plus 1. So what is the meaning of this summation? It's like write the first 13 terms of this I to the power 1 plus I to the power starting from 1 because n is 1 I squared plus I cube dot 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 up to I to the power 13. What is this sum? Plus n plus 1, that is starting from when n is 1, this is 2 till 14. So that is a question which is asked. Now we are supposed to find this sum. So this is equal to, since it is the summation is going to be taken till 13. Okay, so till 13 in the sense I make the groups of 4 4, right? There is one term left in the first group, first summation, right? How many 4 4 terms I can club, right? So first 1 to 4 is one term, right? Then 5 to 8 is a second set, that's also 0, right? Then 9 to 12, 9 11 12, sorry, after 8, 1 2 3 4 is 0, 5 6 7 8, that's also 0, 9 10 11 12 is also 0, only 13 is left. What is I to the power 13? Right, I to the 13 is simply I. First let's calculate I to the 13. I to the 13 is equal to I to the 12, which is 4 into 3 into I, correct? So this is just I. So the first whole term can be simply written as I. Okay, plus now in the second group it starts from 2 and goes till 40, right? Because when n is 1, I to the power n plus 1 is 2. So in this case the sum starts with I power 2, I power 3 dot dot dot, and last term will be when n is 13, it goes till 40. Now we need to make the groups of 4 4 4 and we can make them 0. So I to the power 2 3 4 5, sum is 0. After 5 6 7 8 9, that's also 0. After 9 10 11 12 13, that's also 0. Only I to the 14 is left, right? So you can see that when only I to the power 14 is left, let's calculate I to the 14. So I to the 14 is nothing but I to the 12 into I square. So I to the 12 is 1, I square is minus 1. So first term is I, second term is minus 1. So your answer is I minus 1. So the value of summation n is 1 to 13. I to the n plus I to the n minus 1 is simply I minus 1. Alright. Alright. So next is